So to solve this problem, we're going to use the ideal gas law equation, which is PV equals nRT. Pressure times volume equals N times R times T. Now, N is the given number of moles. R is a known value, which equals 0.0821 liters times ATM, which is our pressure, Kelvin times moles. So we're going to start by filling in what we know. P equals 5.60 ATM. We're given that in our problem. V equals 12.0 liters. N equals 4.00, the number of our moles. R is our known value, 0.0821 L ATM over KMOL. Yes. So now we have PV equals NR, and T is the value that we're going to solve for. Next step is we're going to plug our values in an equation form. 5.6 ATM times 12 liters equals 4.00 moles times the given value 0.0821, which is R, times our temperature. And then we're going to go through and cancel what we can algebraically. So 5.6 ATMs, 12 liters, equals 4.00 moles and 0.0821 L ATM over moles times Kelvin times the temperature. So we can go back and look that we have moles on the top, moles on the bottom, and they can cancel. Okay, cut. ATM times the 12 liters, we come up with 67.2 ATM times liters. That's not how you say that. So then we're going on the other side of the equation, and we're going to do 4 moles times R, which is 0.0821, 0.3284 is what we come up with, and that is liters, atmosphere over Kelvin, and then we have temperature still ready to solve for. So in order to get rid of temperature on this side, we're going to divide the entire equation by R, 0.3284, 0.3284 on both sides. We're going to get temperature on this side by itself, and we're going to divide by 0.3284 liters per atmosphere over Kelvin. So these things canceled, and you're left with just temperature on this side, which means we have 67.2 liters per atmosphere divided by 0.3284 liters per atmosphere over Kelvin. So we're going to be left with Kelvin, which is equal to our temperature. We're left with, when we do our division, we're left with 204.6 Kelvin equals our temperature. And now we have to look back at the top of our problem and decide how many sig figs we're going to use. So we have 3 significant figures, so we're going to round 204.6 to 205. 205 degrees Kelvin equals temperature.